How do spacecraft dock using orbital maneuvers? Have you ever wondered how spacecraft manage to connect in the vastness of space? The process of docking involves a series of carefully planned orbital maneuvers that ensure two vehicles come together safely and accurately. To start, both spacecraft must be in the same orbital plane, meaning they share the same path around Earth. The spacecraft that is actively maneuvering is known as the chaser. This chaser typically begins in a slightly lower orbit than the target spacecraft. Since lower orbits have higher speeds, the chaser moves faster and gradually approaches the target. As the chaser gets closer, it performs a series of controlled velocity changes known as orbital maneuvers. One key maneuver is raising its orbit to match the altitude of the target. This action slows down the chaser's relative speed, allowing the two spacecraft to synchronize their orbits. A common method for this is the Hohmann transfer, which is a fuel-efficient way to transition between two circular orbits. When the chaser is near the target, it enters the proximity operations phase. During this stage, small thrusters are used to fine-tune its position and speed. The approach speed is reduced to very slow rates, usually around 0.3 to 0.6 meters per second. This slow speed is crucial for safety and precision. The chaser often approaches along a radial direction toward Earth, known as the R-bar approach. This method has safety advantages, since any failure would cause the chaser to drift away instead of colliding. The actual docking process requires aligning the docking ports of both spacecraft. The chaser may perform a transposition maneuver to position itself directly in front of the target's docking port. This involves careful adjustments to avoid any collisions. The final approach is executed slowly until the docking mechanisms engage. Throughout this entire process, spacecraft relying on onboard sensors and guidance systems. These systems include visual markers and relative navigation instruments that help maintain precise control. Closed-loop control systems continuously adjust thruster firings based on real-time data, ensuring accuracy. Practical applications of these orbital maneuvers can be seen in crewed missions, such as the docking of SpaceX's Crew Dragon with the International Space Station. They are also essential for cargo resupply missions and the assembly of modular space stations. Mastery of these maneuvers is vital for maintaining a human presence in space and for servicing satellites. In essence, spacecraft docking is a complex dance of orbital maneuvers that starts with matching orbits, followed by a careful approach and final alignment. Each step is executed with precise control to ensure a safe and successful connection in the unique environment of space.